5.2, solving one-step equations. We're going to talk a lot about inverse operations in the next little bit. And the thing about inverse operations is that they undo. So if I were to say 5 plus 3, if I were to undo the adding, I would subtract 3 to get 5 all by itself, because 5 plus 3 is 8, minus 3 is 5. So if we were to say the inverse of adding, that would be subtracting. The inverse, and these are just ditto marks, okay? It means the same thing. The inverse of subtracting is adding. The inverse of multiplication is division. And the inverse of division is multiplication. So let's do an example of multiplication. If I said 15 divided by 3, the way that we would get back to just 15 is we would multiply by 3. Why? Because if we multiply these fractions together, 15 times 3 is 45 divided by 3. What do we end up with? We end up with 15. So if we divide something and multiply it by the same thing, we get the original amount. Another way that we can think about it is if we have 15 divided by 3 times 3, is we can cancel a numerator with a denominator. So 3 goes into itself once, 3 goes into itself once. 15 times 1 is 15. 1 times 1 is 1. So 15 over the 1 is the same thing as simply 15. So solving one-step equations requires us to only apply inverse operations, and that's it. So I want to add one more thing to one more instruction. We want to verify. So we want to solve and verify, and I'll show you a technique to do that. So the name of the game is always to isolate the variable. So the variable in this equation, this first one, y minus 6.3 equals 10.7. The y is the letter, so we want to isolate it. So we say y minus 6.3 equals 10.7. Let's go back up to our chart here. We're having a subtraction here, y minus 6.3. So let's look here. The inverse of subtracting is adding. So what we want to do is we want to add 6.3 to this side. Because if I say y minus 6.3 plus 6.3, this creates 0. So minus 6.3 plus 6.3. But equations are like balancing acts. What we do to one side of the equation, we must do to the other. So if I were to put my little dotted line here, I know that on this side I need to add 6.3 to get y by itself. But on this side I need to also put 6.3. Otherwise it's not equivalent. So y minus 6.3 plus 6.3 is simply y. And 10.7 plus 6.3 is 17. So we've solved it. Fabulous. And I'm going to put a box around my answer. What we want to do next is we want to verify. We can always check to see if an equation is solved correctly, because if we substitute y for 17, so if we put 17 in for the y, we should be able to get 10.7. So I'm going to write left-hand side and right-hand side. I'm going to create a little t-chart. So on the left-hand side, we have y equaling, y minus 6.3. And on the right-hand side of that equal sign, we have 10.7. Now there's only one side that we need to do fancy footwork around. This right here is just a value, so we don't have to do anything to this side. But I see a y here. So instead of writing my y, I'm going to substitute 17 in here, and I should get the right-hand side equaling the left-hand side. So I'm just going to zoom in here. So instead of y, I'm going to write 17, and you can always put a bracket around it, just saying that this is what I've substituted, 17 minus 6.3. And let's grab our calculator. You can also do this in your head, but I just want to show you. 17 minus 6.3, we should get 10.7. And look at that. We get 10.7. We say left-hand side equals right-hand side, and we have verified it. We're going to do the exact same approach to this. Now with this question, we're noticing that we have addition. The opposite, or the inverse, of addition is subtraction. So instead of, we want to isolate this f, but we have added to the f, we have 7.7. So what we want to do is we want to subtract 7.7 from the left-hand side. And on the right-hand side of the equal sign, we also, just to keep it in balance, we must also subtract 7.7. So f plus 7.7 minus 7.7 is simply f. F equals 14.5 minus 7.7. That equals 6.8. So I'm going to put a box around it. The next step is always going to be verifying. So I want to make a little t-chart, left-hand side and right-hand side. Now when we go to the original equation, the left-hand side of the equal sign is f plus 7.7. And on the right-hand side of the equation, we have 14.5. Now it's just a coincidence that in both examples, the right-hand side is already solved for. And in fact, in all 4 examples, the right-hand side is solved for. Sometimes you're going to see a variable in the right-hand side, sometimes you won't. You just have to look at each equation differently. So I don't have to do anything to my right-hand side, it's simply 14.5. But on my left-hand side, I need to substitute in this f because I know the value of it. It's 6.8. So I can put this in brackets, 6.8 because I'm substituting, plus 7.7. I'm going to grab my calculator here. 6.8 plus 7.7. Crossing my fingers, I hope it's 14.5. Look at that. It is. So left-hand side equals right-hand side, and we are verified. And I can sleep easy because I know that I've answered my question right, because left-hand side equals right-hand side. When you get to grade 11 and you're verifying your equation, sometimes the left-hand side won't equal the right-hand side, and that tells you something about your equations. In grade 9, we simply verify so that we can know that we have the right answer. However, in grade 11, soon, in a couple of years, you guys will be using the verification for a different way or a different reason. Okay, so what we have here is division. P divided by 4 equals 3.4. The inverse of division is, what is it now? Yes, it's multiplication. So what we need to do is we need to multiply both sides by what it is divided by. Now, P is divided by 4. Sometimes it's tricky to decide what you're dividing by, what you're multiplying by, but the variable, which you want to isolate, is divided by 4. So we need to multiply this side by 4, and we need to multiply this side by 4. When I multiply P divided by 4 multiplied by 4, essentially we're saying P times 1. If I can just step it out a little bit further, I'll say P times 4 over 4, which just equals 1. And 3.4 times 4 is 13.6. Because I know 4 divided by 4 is 1, I can just say P, because P times 1 is simply P, equals 13.6. Now I need to verify. So left-hand side and right-hand side. And remember, we're going to the original equation. So my left-hand side of the equal sign is P divided by 4. And my right-hand side of the original equation is simply 3.4. See, but I know that P is 13.6, so I'm going to substitute my P here. So I'm saying 13.6 divided by 4. Remember, we don't have to do anything to this right-hand side because it simply is just a value, 3.4. And 13.6 divided by 4, let's see. 13.6 divided by 4. Let's hope it's 3.4. Oh, yes. 3.4. So we know that left-hand side equals right-hand side, and we're verified. Last but not least, let's work with this last one. So I know that 3 is multiplied by v. If we would put brackets around that, it would be a little bit more clear. But whenever you have a coefficient, it's multiplied by the variable. So the inverse of multiplication is division. So what I need to do is, since v is multiplied by 3, I need to divide both sides by 3. 3 divided by 3 is 1, times v is going to be simply v on this side. 15 divided by 3 here is 5. So I have my solution here. Let's verify it. The left-hand side of the original equation is 3v, and the right-hand side of the original equation is 15. Don't have to do anything to the right-hand side because it's simply a value, but I have a variable here that I need to substitute for. V equals 5. So I'm going to say 3 times 5. I don't need a calculator for that. 3 times 5, that's just my times tables, is 15. 15 equals 15. Left-hand side equals right-hand side. And we're verified. So in summary, to solve variables or to solve equations, we need to isolate the variable. To isolate the variable, we need to use inverse operations. So let's just create a handy dandy little chart. So we can say original operation and inverse operation. So if we start out with addition, the inverse operation is subtraction. If we start out with subtraction, the inverse operation is addition. If we start out with multiplication, the inverse operation is division. And if we start out with division, our inverse operation is going to be multiplication. We know we've reached the correct answer when we verify, and left hand side equals right hand side.